A new day call for a new video. Isn't that a good saying? And it's Friday today. What a beautiful day. And just in the mood for another video. And I think we're going to make two today. Let's hope we have time to make two. So this is a continuation of our series on linear programming. And we still have a little bit of work to do. Not to expand on linear programming per se, but to use different methods, to look at what methods are there available to work on general equilibrium. So let's continue. So, but before I go, just want to say thank you very much for your loyal support. Thanks for all you guys that subscribe. For those that haven't subscribed, please do so, and please share the videos, like, share, hit the bell. You know what to do. It does help a lot for the algorithm and so forth and so forth. So in the previous video tutorial, we basically calculated the X and Y that will minimize our Z. Remember, that's our objective function. Our objective function is to find the X and Y where we will minimize Z given these constraints. The minimum Z will be 0 and 0 in ideal, but we can't because it has to be positive and it has to meet these sets of criteria. So X must be a positive number and Y must be a positive number. Both of them must be bigger than 0. So what are that X and Y that minimizes our Z as our objective function? And as I said, we plot our constraints and we find what we call our feasibility region. And then we calculate the coordinates of these 3 points in this particular case. Those coordinates are then the X and Y values, and we add those X and Y values into our objective function, and that will give us the point, or the X and Y, where we satisfy our objective function. Okay. So you can already see all the applications that one can use this for. Okay, now this is again still fairly simple, but we always start with simple and then we progress. And I said, it's not just about linear programming, it's also about Excel. It's playing around in Excel a little bit. Okay, so that's one way of doing it, using graphical illustrations and mathematics to calculate or to find the X and Y for our objective function, in this case a minimization objective function. But as I said at the end of the previous video, we can also use our solver tool. Now solver will find under this data tab. It sits there. Okay, if it's not activated, then file, options, add-ons, analysis tool pack, okay, or solver add-in, sorry, go. And then you select it, and okay, I'm not going to press OK because I already have it. Then it should sit somewhere there. Okay, if you have problems, let me know, and then we can solve it, can sort it out for you. Okay, so there's our solver function. Now, to use our solver function within Excel, we have to have a basic setup in Excel. Okay, so we can't use this setup in Excel to perform our solver. We have to have a basic structure of a basic setup. I'll make this a little bigger. We have to have a basic setup of a basic structure to perform our solver function. So what do we have? We already have some. We know the Z. Okay, we know the Z, and that Z. Okay, that Z value we want to minimize. Okay, so that's going to be our objective function. Our function is to minimize, let's put it in blue, to minimize Z in blue. We know there's coefficients, 11 and 3, that comes from that. So we need to find the X value there and the Y value there that minimizes the Z value. Fortunately, I think I've got pencils here, so here I can actually draw. Don't know whether I have a pen. Yeah, they draw. Okay, so I've got my X coefficient and Y. So I need to calculate an X value and a y value, and that times that plus will then give me a minimum value there. Okay, so what I'm going to do is I'm going to give this also I'll give this a, let's say, a light purple. Oh, sorry, not that one. Here, light purple. So this is where we want to display the x value and the y value. We know, well, in this case, it's going to be 2.5 for x and 2 for y. So that should become a 2.5 and that should become a 2. And that 2.5 times 11, that times 3 must give us this value. So we're going to say that value is that times this plus that value times that value. Okay, so if I put in 2,5x and 2 there, you see it gives me 33.5. 33.5. Okay, so that's what it should be. Okay, so that's now the structure of our minimization. So solver will solve this part for us. Okay, then we have constraint 1. We have constraint 1, so let's just do C1. We have constraint 2, and we have constraint 3. Remember, I'm not including this because it's identity, but obviously if that's positive values, then we satisfy this identity. So those values we can just manually or visually inspect to make sure that it satisfies this particular identity. Okay, so we've got for our first constraint 4x and 1y. We've got for our second constraint 2x and 2y. And then for our third constraint we have 4x and minus 5y. And so what we want to do is to generate, let's put it, these values, okay. Now, what's going to happen is the value there will be 4 times that, 1 times that. And we want to make sure that the value there is smaller or equal to 12. And we want to make sure that that value there, and so we're going to copy that value there, is smaller or equal to 18, because remember we must work within these constraints, and this value must also be equal to smaller than 0. Okay, so solver will also then calculate this. Now that value there is equal to 4 times this value plus 1 times that value. And this value there must be less than these values. Otherwise, so for example, so let's pull this down. Let's pull this down. So once that we fix is E4. So that would be that one that we fix there. And then F4, that is the one that we fix there. So for example, okay, so for example, sorry, Paul, apologies for that. That happens when you're at work and trying to do these things. It's not as nice as being at home. Anyway, so remember, why is it doing that now? Okay, let me just get everything. Okay, so remember, so if I, for example, put in now the 2.5, and the 2 there, as we said, we're minimizing we're achieving our objective function by x being 2.5 and y being 2, then we must still satisfy our constraints. And you can see there, with those two, with the x and y value of 2.5 and 2, for constraint 1, the outcome is 14, which is smaller or equal to 12. So that one is checked. So we satisfy that one. The 2 and the 2 times 2.5, 2 times 2, that gives you 9, which is smaller or equal to 9. So that we, however, here we have full capacity. We're using all our constraints. We're using all our scarce resources. But here, with constraint 2, we don't use all our resources. So what we do here is we call that slack. And we're going to do that calculations at some point as well. So we can still actually use some resources here if we want to. And then obviously this and this gives us 0, which is smaller or equal to 0, so that satisfies our constraints. So with this x and y, we're minimizing our z, we're achieving our objective function while simultaneously satisfying all our constraints. And that's what we want. Okay, so let's quickly, okay, so now we have the 2.5 and 2 because we've done all of this work. But let's say we didn't do this. We only have our set of equations and we set up our structure. How are we going to do this now? How is this going to work now? Okay, remember, we need to calculate those values now. So Solver is going to do this for us. Okay, so Solver can do this simultaneously for us. Okay, without doing any of these. Oh, so we don't have to do any of these things. Okay, so let's go and have a look. So we're going to go to data and we're going to put in Solver. You see Solver, the first thing is ask you this objective. Now this objective is this value here. Okay, that value there, this is the value that we want to minimize. It's not a maximization objective, it's a minimize, and we want to minimize that value. Okay, by changing what variables? By changing that two variables. Okay, so it's going to generate the values that's in these cells, and the values in this cells must minimize that value. Okay, so that's fairly straightforward. Now we need to add in our set of constraints. So we're going to add our first constraint. So our first constraint is this cell reference, or sorry, let's do it individually. That cell reference, and you can see here, it's got the wrong side, so we must change it. It's smaller or equal to that side. Okay, so that's our first constraint. So we add that. Now, second constraint is this one, and that one is smaller or equal to that one. And our third constraint is that one is smaller or equal to that value. Add, and you can see, there's our three constraints. We must make sure that this is marked. They must not be non-negative. Remember, this is this identity. Make unconstrained variables non-negative, i.e. satisfy this identity. Okay, so let's just make sure before we press solve, and then obviously it's a simple linear function. Simple linear function. Yeah, so make sure this is ticked, that box is ticked, because that box is our identity saying must be non-negative. So let's go through this again quickly. So that's our objective function there, the outcome there, it's this value there. So we want to determine that value, that's a minimum when we use those two values. And adding those two values must satisfy these constraints, meaning that must be smaller or equal to 12. This one must be bigger or equal to 18, and that one must be smaller or equal to 0, smaller or equal bigger. And then we say solve. So let's have a look and see. So let's just say keep solver solution, return, outline the reports. Let's just do that, press OK. And it should have created, where is it now? So let's have a look, where did it now? Answer report 3. There it is. So I think it's this one. 27, no, 30, 27, no, that's not the right one. Sensitivity answer report 2. 2004. So where is this one now? Where did it? So let's have a look and see. Yeah, so there you see it is calculated the 2.5 and 2.5. Okay, so it generates reports, but I don't think there's too many. Let's have a look and see. Okay, so let's see if I can hide. So it's gonna get, there's 27 sensitivity reports, there's 25, 07, 30. So I'm not sure. Okay, so I'm just looking for where it generated those reports. But anyway, let's redo it again. So you'll see. So we're gonna go to solver. and it still has this. Okay, so we're going to minimize that function there by changing these variables, and these variables must also satisfy these constraints. This identity is simple, so we're going to press solve. So it runs through the whole thing. Let's see, keep return to solver parameters dialog, keep solver solution, reports. Okay, there we go. Answer, sensitivity, limits. There we go. And we're going to press OK. So it's going to run. You see, there's the reports is in 4. That's what I was looking for. But you can see now it generated the 2.5 and 2 and the 33. So it's done that. Remember, it was empty. So it gives us exactly the same calculations. And here we got the 9, the 12, and the 9, and the 0, which satisfy also our constraints. So there is our solver to generate our x and y that satisfy our objective function and constraints. Now we can go into the reports. There's answer report. Let's have a look. It's 10:10. Okay, 10:10 today. Let's cell D3. Which is cell D3? Where is my? It must just go to where my. So D2, D3. That is okay. So it solves D3 optimal solution Z original and then the final value. Okay, so it gives us that 33.5 value there. And then here it gives us our constraint. So our constraint is value is 12 there, which is 12 there, which is that is equal to our total. So there is no slack. You see there's 9, and as I said to you, there's 9, so meaning there's slack of 9 again. There's 9 slack, and then for the last one, there's 0 slack. So that's basically just in a different way expressing what we've presented there. Sensitivity, why didn't do a sensitivity report? 10:10:10. Okay, so this sensitivity report. So you can have a look there and see what that means. But anyway, that is the solver. Fairly straightforward. Now we can add X, Y, Z, blah, blah. We can add how many of these variables, and we can add how many of these constraints, and it will generate, whether it's 2 variables or 100 variables and 1,000 constraints. Solver will calculate the optimum solution for you, that based on your set of linear equations. So that's solver in a nutshell. Very nice. So just confirm solver. It's an add-in that you have to install in Excel, and that's just the layout of it. So again, remember you have to have, oh, sorry, cancel, okay, okay, cancel, so objective function. Okay, so it's just so remember you have to have this layout, this structure. Come on, don't want to do this. Okay, it's going to keep on because it's not in there. So it has to have this specific structure. Okay, which is straightforward, nothing to it, very straightforward, nothing to it. And then we select our cell where we want to minimize, in this case, our objective function by changing what values. And if there's more, you just add more, and then you're subject to your constraints, which is this value must be less or equal to that value, etc., etc. And that's it. Really nothing to do. And then, as I said, make sure your identity is, and then solve. You can just put all those reports if you want those reports. And that's really that. That's the solver. Fairly straightforward, fairly easily, and it saves you the hassle of doing all of this stuff. However, I, to some degree, like to do the graphs and the stuff because it visually presents it. And if you have a blueprint, if you have a template, then it's basically fairly straightforward. And as I said, within this, we can add many, many more constraints. But as you can see, the more constraints you add here, the more, I wouldn't say visually impaired your graph becomes, but if you have 1,000 graphs here, it becomes problematic. So for too simple to demonstrate it, I like to go the visualization route, the basic math and visualization route. But once you have a lot of X and variables, a lot of constraints, then I think we're going to have a problem with the traditional set. So then we use the solver. Okay, then we use the solver. Um, so that's one way of doing it. Now, obviously, as you guys know, I like R Studio. I love R. So the next video will focus on R, where we're gonna do exactly the same here, but just do it in R and see what R allows us to do. Okay. Um, so that would be then the third method. So the first method is our general maths and graphs. Our second method is a solver. And our third method will be RStudio. I'm sure there's other programs that you can also use, but these are free. They are open source, and they can basically do everything that all these fancy programs can do. Okay, so that's the solver function within our studio that can help you or that can generate your variables for your objective function. And that's meeting satisfying your constraints. So with that said, nothing else. Yeah. With that said, thank you for watching. And again, please like, subscribe, share the video. And I'll see you on the other side.